Hi, everybody. My name is Bob Gardner. I'm a Senior Vice President with SCS Engineers. I oversee our solid waste practice across the country. I've had the great pleasure of working with Dr. Katami for a number of years, and I consider Dr. Katami probably one of the foremost leaders in innovative landfill design that I've had the pleasure of working with, and I've been in this business for 40 plus years. So hopefully you'll find this particular webinar helpful relative to managing probably one of your most important assets if you're a landfill owner and operator of a facility. Being able to maximize the utilization of your landfill airspace and to design your landfills that can minimize both construction and operational costs is critical. Dr. Katami is also a vice president with SCS Engineers. He is what we consider our national expert in landfill design, construction quality assurance, and elevated temperature landfills. He kind of leads up our landfill design practice within the company. He has some 40 years of experience in mechanical and structural and civil engineering. And he works on probably some of the most complicated and challenging landfill projects that we have in the country. And one of his skill sets is really kind of mentoring technical professionals, and he has a real passion for teaching the younger generation with regards to the ins and outs of landfill engineering. And hopefully today you'll get a sense of that expertise relative to how you can best manage your landfill assets. He's a registered professional engineer, and so hopefully you will enjoy the presentation today. So I'll turn it over to Ali, and I'll be monitoring the question and answers, and as appropriate, I will jump in and ask Ali questions, and also at the end of the presentation, continue to answer questions or bring those to Ali's attention so he can answer those as we go along. So Ali, I'll turn it over to you to go through your webinar presentation.
Thank you, Bob. Thank you for the kind introduction. And thank you, Diane, for setting this up. It's really a great opportunity to communicate with our solid waste community and share information with everybody. See if that will come useful to the audience in the future. Starting with the landfill assets. Landfill assets could fall in the categories of airspace, equipment, and buildings. There may be a few other things, but may not be as significant as these three items. The far most important asset for landfill owners is the airspace. It's a commodity that is limited in inventory, and it ties back to the permits that gets issued for the landfill, and it's a limited quantity. As we all know, it is almost impossible to come up with a greenfield landfill site nowadays, unless the owner wants to spend a ton of money over a very long period of time to overcome all the hurdles associated with regulatory, zoning, public opposition, and all of those over a very long period of time. And if they get lucky, they will end up with a greenfield site for a landfill. Short of that, it's the existing landfills. Existing landfills are the primary assets for solid waste operations, management of waste for the communities and serving the communities. And we all know that the cost of disposal keeps growing up because the cost of fuel keeps growing up, the cost of materials to construct the landfills keeps going up, wages are going up. So as a result, the cost of disposal keeps going up while we have a limited airspace available according to the permit. Recycling and beneficial reuse of waste is certainly helpful in the process, but there's always some residuals that have to go into the landfill. And over time, it adds up. It's a large quantity that have to be managed in landfills. So it's essential that we make the life of the landfills longer than what they may already be in the permit, in accordance with the permit, and try to maximize the life of the landfills. That plays an important role in the prosperity and economic growth of the communities, whether it is a private sector landfill or a public sector landfill. In both cases, these landfills provide an essential service to the communities around the landfills and beyond. On the planning side of landfills, I have seen, for example, through RFPs or communications with the municipalities that are owners of the landfills, I have seen many cases that they plan, for example, for an expansion to an existing landfill for 20 years of life or 30 years of life. That's good and handy, but keep in mind that 20 or 30 years is not a very long time when it comes to landfill systems. It may sound a little bit extended period of time when you're at the beginning of the 30-year period, but when you go into this process 10 years down the road, 15 years down the road, the remaining life doesn't seem impressive in the long-term planning of the landfill. So our suggestion, our recommendation is go for the largest amount of life that you can for your landfill, way beyond the 30 years, because life goes on beyond the 30 years. And the community do need service from the landfills beyond 30 years. If the plan is for a shorter period, maybe 20 years, maybe 30 years, I would like for you to know that the shorter plans may inhibit or diminish the possibility of further development of life beyond the short-term plan. Well, what does that mean? Let me get a little bit more into that. If the administrators of a landfill, whether public or private, instruct the designer to give them a footprint for a 30-year life, then the engineers are obligated to design the footprint based on the need for 30 years. And along with each design comes peripheral systems, leachate collection sumps, gas headers, condensate sumps, you name it. All sorts of peripheral systems have to be designed and located within or around this footprint that have to serve the landfill operation, construction, and closure at the end. If the designer has not considered life beyond the 30 years, some of these features can be in the way of future expansions when the remaining life ends up to be 15 years or 10 years and the owner wants to expand it further. So be aware that short-term plans could or may inhibit or diminish the possibility of further development of life beyond the short-term plan, which is an important point. And the landfills must be able to serve the community for multi-generational periods. One generation period is not enough for a landfill system. For example, is a kind of the picture in this slide. The top two guys were basically the ones that have been depositing their waste in the landfill for many years. And that the middle guy is considered as an engineer for the expansion. He has to plan for the 2 or 3 generations down the road that they can benefit from the services of this landfill. So it's a generational kind of development that have to come into the picture. And all I'm saying is that go for the longest life that you can when you submit a permit application to the agency for permitting purposes, and maximize the airspace of the facility as much as you can.
Ollie, one of the questions that was asked, and this might be an appropriate place to talk about as you think about long-term planning, is relative to landfills compared to incineration. Obviously, landfills are the final repository, whether it's incinerator ash or whatever. It's the final depository. Even with incineration, you got residuals to deal with. Do you have any sense of the future relative to those two approaches or two technologies? Is it geographically dependent or land dependent or?
Geographically dependent, depending on the complications in permitting a landfill. But landfilling, you all know, that is the least expensive option for managing waste. It is true that it will remain there and you would have to manage it for many years. And the mound of the landfill will stay there physically in place for a very, very long time. And I always keep our colleagues, our friends, our young engineers, that probably the only structure, man-made structure, that cannot be relocated are the landfills. Any other structure can be relocated, could be demolished or whatever. Landfills are sit there for a long period of time. However, if you are in a community that it's very hard to site a landfill within that community, and it's they have gone through the exercise of looking at the other options, different sites, different properties or anything, and proven not to be able to site a landfill in that community, incineration could be certainly an option. But keep in mind that incineration requires a significant amount of investment. Of course, communities can go through bonding of this, but those are all still financial kind of burdens on the community that have to be addressed. And the maintenance of incinerator is significant. While landfill is true that they have to be maintained as well, they have many expenses on the along with the operation of the landfill, long-term maintenance, as well as financial assurance of it. But overall, it's proven to be the least expensive option for disposing of and managing of waste.
Yeah, I mean, I think as I've looked at it, I mean, you look at the distribution of waste energy facilities in the United States, and Florida being the most highest concentration of incinerators, municipal solid waste incinerators in the country. And the reason being is Florida is you got a limited amount of land. And so I think the volume reduction issue has been really kind of an important issue for areas where you got land constraints and that you have to deal with. So thanks a lot for that insight.
It's true. There's also another point. For example, you mentioned Florida. In Florida, the number of incinerators by the public sector is a lot more than the number of incinerators by the private sector. And the public sector, the reason that they lean toward the incineration is that they want to have a landfill footprint within their community, within the county, or within the authority that is in place, which could have 2 or 3 counties in it. But they may not be able to permit the footprint. So they go by the other option, which is the incineration. So again, it depends on the politics, on the ability to site a landfill. For example, I know one of the larger counties in South Florida has tried to have another landfill site for over 10 years. They were not able to site another landfill in their county. So they went back to the drawing board and they designed, permitted, and constructed a brand new, a second incineration at the cost of $700–800 million.
Right.
But it's all bonded, which is a service charge of it is on the community. I'm not saying that it's a bad option, but the situation dictates that.
Excellent.
Continuing with the acreage of the landfills, the acreage itself may seem large at the beginning of the planning period, but after some time, the acreage doesn't look that large anymore in the long-term life of the landfill. Population and waste generation keep growing while the airspace in the permit of the landfill keeps reducing. So it's a kind of a opposing trend in waste generation and management of waste with landfills. So we think that the solution to that opposing trend is innovation. We all have to strive to come up with innovative ways to manage waste as well as increase airspace within a certain footprint of landfill. And I encourage engineers come up with new ideas. For example, the herringbone concept has been around for 40, 50 years. Every landfill that I know from many years ago, they all have herringbone design, which requires a certain amount of structural fill to go in or a certain amount of excavation for deep landfills to be excavated, and the herringbone applied to the bottom of it. Come up with a new idea other than the herringbone. You still need to be able to bring leachate to the sump, but come up with a different geometry, which we have done it over the years, and we have been able to serve our clients in a major way. For example, in less than a dozen of landfills that we have revised the herringbone pattern to an innovative design that we came up with, we have been able to increase the bottom line for our clients for about $500 million. This is only changing the geometry of the base area. We have done other innovative designs that are not in this $500 million additional revenue or additional number to the bottom line. So it is important to innovate. It is important to come up with new ideas. In general, we have come up with a three-step principles. Number one, for a specific property owned by your client, by the owner of the landfill, optimize locations and size of various facilities and operations. For example, you need a footprint for the landfill, you need an area for drop-off citizen drop-off place, recycling, composting, you name it, whatever operations you want to have. Optimize the areas, locate them in areas that suits that operation for a long time. And also in order to have a very good size footprint as much as you can. Then within that footprint for the landfill, come up with designs that maximizes the airspace and come up with optimum designs between the elements within that landfill design that would kind of maximize your airspace. And in the long run, be prepared to downsize facilities around your landfill. And you get to a point, eventually you get to a point that you want more footprint. You have to modify your permit and you need land to expand the landfill laterally over that land. So in that case, you would have to consider eliminating or relocating certain ongoing facilities on site, relocating to an area which may not be effective for landfill footprint, or moving it off-site to another location in order to open land for lateral expansion. These are the three principles we keep in mind in the landfill development. Next, and when we go to best practices, we are going to go over a few things here. And first, we start with those elements that we think should not be on the table per se for consideration. Number one, please do not place borrow pits in the path of future expansions. That is wasting airspace. Borrow pits should be placed in areas that are not effective for landfill footprint, or should be on a non-contiguous property but close by, that minimize the hauling distance. I have seen many cases that when I look at the aerial map of a landfill, I see a big borrow pit right next to the footprint of a landfill. I say, gosh, there are so much airspace wasted because the borrow pit was placed in the wrong place. Another one, leachate sumps. When you come up with a location of leachate sumps, think of future expansion, whether these leachate sumps are in the path of future expansion. Leachate sumps are such that they basically eliminate the possibility of laterally expanding the footprint in that direction. So you need to be very conscientious in terms of future expansion of the landfill. If you're planning for 30 years of life, which I don't recommend that, as we discussed before, think of a 100-year life for that landfill and then design the 30-year life footprint based on future expansions that could be possible in the future. And another feature that may come into the picture is that if you are disposing of certain types of waste outside your footprint that may not be suitable as a foundation for future lateral expansion, do not place those kind of waste. For example, just waste tires. If you want to dispose of waste tires on your property, place them in an area that the future expansion is not going to get them. Do not place it right next to your landfill that you eliminate the possibility of expanding the landfill footprint over that area. And another option, this is a personal opinion. For those who have such facilities in place, please don't take it personal. I have seen over the years glorious scale houses built like Taj Mahals at the beginning of an entrance to the facility in the middle of a very large open area. This kind of things not only makes the scale house super expensive for some reason, for not a good reason, also eliminates the possibility of expanding landfill footprint over that open area. So be reasonable in locating the scale house, the orientation of the scale house, the location of the scale house in consideration of future expansions, because you're going to be needing to expand 20, 30 years down the road.
Ali, one of the comments that was made, and I thought it was a good comment, was that obviously in terms of if your cell development is moving forward and you can use the area and excavate the materials ahead of your cell development, I think that's fine. And most people do that. And I think you were getting at, don't put a borrow pit that's going to have to be there for a long time. It gets in the way of what you need. That would be the thing that you want to keep an eye on.
That's very correct. That's coming up, as a matter of fact, in the next slide that we are going to go over. I have a bunch of items to kind of share with our audience here that is a bunch of do's. We went over the don'ts. Now we are going over the do's. Exactly what you just mentioned, Bob. If you have a very large footprint and you're not going to get to a certain part of it for another 20 years, 30 years, consider leasing that portion out for all sorts of operations, or leasing for private sector, leasing out for agricultural use, that you can use the tax benefits of it. To give you an example, I know of a landfill that they leased out a portion of a future landfill to another third-party facility that built a $4 million metal recycling facility. And this facility has been on the permitted footprint at least for 10 years so far. But 30 years down the road, when the footprint gets to that area, that operation can easily be abandoned, the building demolished, and cell constructed. Consider swapping land with your neighbor. If you maintain your position with the neighbor as a good neighbor, swap land with them, make them happy, get some of his land for lateral expansion if need to. Decommission leachate ponds that are next to your footprint after 30 years. If they have been in service for 30 years, decommission and expand over them and use the newer technology for managing your leachate. If there are peripheral operations, composting, recycling, or whatever, consider relocating them to an inefficient portion of the site or moving them off site in order to open land for your footprint. The same way, demolish structures that have been in service for many years. You can afford to demolish them. The cost of land is more valuable because it gives you more airspace. Certainly plays a major role. And also placing short-term operations facilities within the permitted footprint is a good idea. backfilling, another thing that you can do, backfilling borrow lakes or existing ponds on site next to the footprint with clean debris. We have done that. We permitted the borrow lake to be backfilled with clean debris. Then we performed dynamic compaction of it on it in order to make the foundation suitable for lining system. We constructed the lining system on top of it, and that by itself, a 30-acre borrow lake gave us 5 million cubic yards of airspace, which is what permitted about 7 years ago, is already completely filled. So that's 5 million cubic yards of additional revenue to the owner. And there are many sites with power lines on them, creeks, wetlands, floodplain. Our suggestion is do consider relocating them. We have done the relocation of 300,000 volt power lines around the footprint of the site in order to open a space for a landfill footprint. Creeks can be relocated, wetlands can be permitted to be mitigated for, and land made available for landfill footprint. The same way with floodplain. You can design flood storage capacity somewhere around the property that you basically divert the flood water into that design system and open land for lateral expansion. And a scale house reorientation could be another one, as we discussed earlier. Reorient your scale house, your scales, if you can open a space for landfill footprint. These are all the kind of items that can be and should be considered in the long-term planning for your site. Now that we completed the discussion portion of the presentation, we are going to roll into the second part of the presentation, which is all ideas that we have developed over the years that has helped us to provide, to give, to permit additional airspace for our clients. In the context of optimizing design, base grade innovative geometries can add to the airspace as well as save construction material. The same way with final cover grades. Base grades is basically dependent on the slope at the base of the cell and the slope of the pipe. If you can come up with the geometries that can reduce structural fill volume or excavation volume for deeper landfills and reduce construction period because you have less construction material to construct, whatever you save on the construction material, you will end up adding to the airspace. So you maximize airspace. These are all valuable exercises that we need to consider. And there is also a trend in the waste management communities, and that is, again, the relationship between the landfill owners and the engineers. I would like to see landfill owners basically examine designs proposed and considered for permitting by engineers. Base slope plays an important factor in the quantity of material that you will be constructing in the future. It's the cost, it's the negative to the bottom line. Pipe slope is the same way. If the engineer puts a 2% slope, a 1% pipe design in front of you, just ask the question, tell me why 2%, why 1%? The reason I'm saying it, because many of us, I include myself in it, that have done that many years ago. We go with the standard slopes. And then we check whether the foundation settlement is still okay in consideration of those slopes. If the foundation settlement is 0.5% at the base and we propose 2%, the landfill owner needs to know that and has to ask the question, why there is a 1.5% slope left in there that they have to fill it with dirt? Why not make the base slope 1% if the settlement is 0.5%? The same way with the pipe. I would ask landfill owners to actually do their own due diligence on the designs put forward for permitting for them. And that creates the relationship more engaged in a much better way, as well as innovation comes into the picture. If the landfill owner says, okay, if you're going to have 0.5% of settlement, what if you give me 0.7%? And the engineer has to come up with innovative designs to justify the 0.7% if need to, or things of that sort. Encourage your designer to be innovative in giving you additional airspace. When it comes to final cover, we have seen many landfills around the country with terraces on it. You can go with a straight up 3-to-1 slope, which is the dashed line. The shaded area is the additional airspace you catch while going to a straight up 3-to-1 slope. And the straight up 3-to-1 slope is much easier on operation side of the landfill, and it is much easier on the design features that come into the picture of final covers. I personally have never designed landfills with terraces, and I have been in this business 35 years. Terrace system is a very, very cumbersome system, whether it has to do with operations or whether it has to do with the design of the final cover, because so many different elements come into the picture of final covers. When you have terraces on the landfill, these features become very, very complicated. Three-dimensional geometry has to be met in terms of stability, in terms of water flow to the swells, to the ditches, water flow through the downshoots, all the geometric features that have to come together to make things possible. And
you accomplish that more on the final cover system in terms of tack-on berms to deal with the long slopes and breaking those slopes up, right?
That is very true. Next slide, you're gonna hit on that. If you have a straight 3-to-1 slope, the tack-on berms / swells would be on the slope, and it can be located wherever necessary at the time of construction of the cover system. Cover system normally gets constructed in partial features, and the location of the swells plays an important role in the partial closure designs. If you have terraces, it's very difficult. You're set with the location of the ditches on your cover because the terraces are set, and you have to spend a lot of money on additional soil in order to create the longitudinal slope and the transverse slope on the terraces to make things happen. At the end, when you come to the low point of these terraces, it's a very complex geometry, making the pipes fit together with the downshoots and the lateral chutes that drain the swells. So when you go to the straight up 3-to-1 slope, the downshoot is very simple system, and there are lateral chutes involved. This is a typical cross-section of a tack-on berm. Straight up geomembrane and the drainage layer above it. The 2-foot thickness, for example, is a straight up with some sections added soil to create the swell behind it. Again, the swell would be sloping at the 2%, 3%, whatever your design needs to be. And you can adjust the size of the swell depending on the runoff quantity reaching each swell. When we come to the downshoot, it's a very, very simple downshoot system. 2 pipes. Normally I use 2 pipes. You can design it with 1 pipe, with 2 lateral pipes. This is the kind of a picture of a construction of the cap. The 2 pipes that you see are the downshoot pipes, and the stickouts are the lateral pipes that connect the downshoot to the low point of the swells. All these pipes can be fabricated off the slope and pulled over the slope and soil pushed around it. It's a very simple construction. This is the outlet of the downshoots. We normally put fabric foam around it, which acts as the energy dissipator. And this system is very efficient in conveying water from the slope through the swells, through the downshoot to the bottom perimeter ditches.
And you've deployed this in some of the rainiest parts of the United States.
Yes. The first system that we constructed of this type goes back to 1997. We have never had to go back and do any maintenance on it, and has been performing well without any problems all these years. This is a view of the lateral chutes at a certain swell level. The opening to the pipe opening is the opening to the lateral chute connected to the downshoot, which is in the hump between the two lateral chute inlets. There's another one that you don't see in this picture. And these pipes are located at the low point of the swells. And the downshoot runs from top to bottom of the slope in the hump that you see between the two openings. Again, it's a very simple, straightforward construction and very effective. It's not like the geometries that you have to deal with the terrace system. Now let's touch upon a few things about the gas and leachate. We all know that landfills have to carry leachate to the bottom and gas to the top through the vacuum system. Some landfills are very thick, 200, 300, 350 feet. We are approaching landfill with 400 feet of waste. So you can't really install gas wells at the end of the life and cover only 100 feet of the 400 feet waste. This is a tiered system. Each tier may be around 100 feet in thickness. This is an exaggerated scale, not to scale system. And the pads provide continuity or interconnectivity of wells that you see in this schematic view. Leachate can flow down through the entire thickness of waste, and gas can flow up through the entire thickness of waste. It is a matter of construction of it in a proper fashion. Going through the details of construction of this system is outside the scope of this presentation, but we have a very detailed way of constructing this system in a very effective manner that we can control gas emissions every step of the way, and you end up with a very proper system for moving liquids down to the bottom and vacuuming the gas out from the entire vertical column of waste. And each pad, again, you can have fingers sticking out of the pad on a horizontal level. These can help to collect liquid from perch zones of leachate or convey gas to the main well that is connected to the pad for removing the gas from the landfill. Or you can have removal blankets, leachate removal blankets, gas and leachate in the middle of the landfill at any level. The level is shown here 2/3 below the top of the landfill, which is the valley of the heat generation in the landfill. These blankets can work in conjunction with a tiered gas well system. They are very inexpensive to construct. They can go anywhere that the operator deems necessary, and it helps to remove leachate from perch zones or remove gas from areas that is kind of need to remove gas from. Another subject to discuss, gas at the bottom of landfill. We all have experienced gas pressure buildup near the bottom. This is, again, a simple idea that we have been implementing over the past 6-7 years during construction of new cells. The lining system goes in, the geomembrane goes in, the geocomposite goes in, the leachate collection system in the middle of the brown shaded area, which is 2 feet of sand, goes in. Then we install very inexpensive piping system on top of the sand near the completion of the cell. These pipes extend to the outer limit of the cell, and they can be connected to the vacuum system to remove pressure from the bottom of the landfill. I have had cases that pressure was so high near the bottom of the landfill that affected the flow of leachate through the geocomposite void. I was standing right next to a composite that has 2 inches of water standing on it, but not flowing down the slope through the composite. That is only due to high gas pressure that fills all the voids in the sand as well as geocomposite and can affect the flow of leachate through the composite. With these pipes, you can easily address that matter and make your investment do what it needs to do. You invest a lot of money on the drainage layer, on the geocomposite leachate collection system. And if it cannot perform, it's just waste of money. These little pipes connected to the vacuum can easily make that possible for leachate to flow easily to the leachate collection system. We also connect all the risers to the vacuum. Many engineers do that nowadays. It can be connected to the LCS cleanout, LCS pipe cleanout. It could be connected to the riser of the primary system in a double lining system, or to the riser of the secondary portion of the lining system. All can happen right behind the structure near the sump. It's fairly easy to do it and very practical to do. And then the pipe, the vacuum line goes up to a gas header, or it goes to a gas valve to apply vacuum to it. Condensate system. We have all seen condensate sumps constructed on landfill slope, gas headers at 5% slope constructed on the side slope of the landfill, condensate force main, compressed air lines, all of those on the side of the landfill. These are major components of the gas management system, the liquid in gas wells management system. What we are proposing is that what we have been doing it for the past many years, we put all these systems in the perimeter berm of the landfill. When you install it in the perimeter berm, there are no settlements involved anymore. The gas header can be constructed at 0.5% slope instead of 5% slope on the landfill. The condensate force main all in the perimeter berm, the compressed air line in the perimeter berm. All of these can be constructed at the time of a new cell construction, and all will have stub-ups that can be connected to in order to bring these services over the landfill surface to the gas wells in terms of vacuum or condensate force main or whatever is needed, liquids from the gas wells.
So Ali, I think that what this kind of gets at least as I listen, goes back to one of your earlier comments regarding really thinking ahead and thinking 30, 40, 50, 60 years ahead, and the infrastructure that you need to support your landfill life. If you can get that in early and in places where you're not going to have to deal with settlements or deal with those kinds of issues, you're probably ahead of the game with regards to the performance of those systems.
You're absolutely correct, Bob. I'm glad you mentioned that. This is all long-term planning. This is all being able to see, as you said, 30, 40, 50 years down the road. Not only your field of vision should not be on 10-year or 20-year. It should be much longer field of vision in terms of planning for the landfill. This is an example of that condensate sump that is in the perimeter berm. Perimeter berm is going to be constructed around it. And these are the cleanouts to the gas header, again, in the perimeter berm. The stub-ups for the compressed air lines, stub-up for the leachate condensate force main. These are all sampling ports with valves to close off sections if needed. And these will be very accessible to the maintenance crew. They can easily reach it and do their maintenance. They don't have to struggle, get on the 3-to-1 slope, do any sort of maintenance to it. Leachate collection pipe and gravel. This is a kind of important matter. And I would like to kind of share this information very closely with our audience. One of the problems that happen at the leachate collection pipe and gravel is the clogging of textile. There's always a textile that wraps around the gravel that has the pipe within it. And there's always a textile as the upper layer of geocomposite drainage layer. So the leachate that is flowing down the slope in the composite within the geonet component has to pass through the upper geotextile of the geocomposite and has to pass through the geotextile wrap of the leachate collection pipe gravel setup, and then only at that point can enter the gravel. and then the pipe. The passage of leachate through two geotextile can cause clogging, serious clogging of the geotextile over long term. Come up with a design. We came up with one like this. Come up with a different one that you can eliminate the possibility of clogging. Here, we basically eliminated those two geotextiles from the design altogether. And the leachate in the geonet flows directly into the gravel and into the pipe. Doesn't pass through any geotextile that would cause clogging. This helps to in the system to remain healthy and effective, and for removing leachate from the cell through the leachate collection system. Next, this is some pictures of during construction of it. The one to the left, the layout, the layers below the pipe is already set. A few inches of gravel below the pipe sits on top of the few inches of gravel. And the next figure on the next picture on the right, it shows the mounding of gravel. And the textile goes only over the gravel, doesn't wrap around the gravel. This is to eliminate the wrapping textile. And on the left, we eliminated the upper geotextile of the geocomposite. So by eliminating these two geotextile, you eliminate the very high possibility of clogging in that system. Leachate seeps. There is a kind of a common perception that when you install covered geomembrane, all the seeps disappear. I have a news for you fellows, my colleagues. Seeps keep going. Seeps continue if the source of the seep is not directly below the geomembrane you install. Seeps continue flowing down the slope directly below the geomembrane to the toe of the slope. I can tell you, in 2020, I have had 2 cases that they ended up with a ponding of leachate seeps below the covered geomembrane, and they had to excavate the soil. They have to open the geomembrane, remove the water, close the geomembrane, put the soil back, and only by doing so, they restart another cycle of the same problem that was going on over the past 3 years, that they just repaired it. The same cycle shows up 3 years down the road, and you would have to spend a ton of money to repair it again, doing the same thing. Why not we design a leachate tow drain system that would, in an engineered way, manage the seeps? And that's what you see here, LTDS, leachate tow drain system below the covered geomembrane. At the bottom of the slope, you design this system, you connect this pipe to cleanouts, to primary system risers, or you provide dedicated pipes that can drain the liquid into the leachate collection sumps. Since the geomembrane is covered, geomembrane is tied to the bottom geomembrane, it's completely sealed. So the liquid you collect in this system has to be diverted into the leachate collection system inside the landfill. We've done this for the past 20 years. Basically, I think we were the inventors of this idea 20 years ago. I had never seen any designs that would have a leachate tow drain system in it 20 years ago, and we developed it. And we have had very good success record on it. This is an example of it. The panel that you see on the slope is the geocomposite component of the leachate tow drain system. The burrito that the fellows are standing next to is the tow drain, leachate tow drain burrito. And this entire system will go under the cover system geomembrane that gets welded to the bottom geomembrane. It's completely sealed by the geomembrane, and any liquid coming down the slope below the cover geomembrane gets collected by this system and diverted back into the leachate collection system within the lined area of the landfill. A similar but different system will be above the geomembrane cover geomembrane, and that is the rainwater tow drain system, we call it. Basically, rainwater that percolates through the upper soil of the closure, gets in the composite, flows down the slope. I have seen many different designs out there by different entities, but we have had a very good experience with this system that you see on the screen. We have been constructing this close to 20 years at our landfills. And it's a simple construction, a geomembrane flap, and the area behind it is where the burrito will be sitting, receiving water from the composite. At certain points, we'll have a lateral pipe draining the liquid into the perimeter ditch. Very simple, inexpensive system, very effective, and maintenance-free. As long as the slope remains intact, there is no problem to the impacting the flap. This stays in there, and I haven't seen impact to the flap after completion of the cover system at any sites. This is
one of the questions that was asked, kind of going back to the leachate toe drain issue, was have you had any experience of scaling with mixing toe drain liquids coming below the cap with the leachate sump liquids?
Not really, because the amount of the liquid, keep in mind that the amount of liquid reaching the leachate toe drain system is not much. The amount of liquid coming out of the seeps, even before placing the geomembrane, is not significant. You see a small stream coming out. You put the geomembrane on it, some of these streams persist, and the liquid gets into the leachate toe drain system, but it's not a very large quantity, like the amount of liquid that you collect from your leachate sump could be in the order of 800 gallons per acre per day coming out of the typical leachate collection sump. But the amount of seep that you collect and divert to this sump are small quantities. Okay. But there are needed systems to manage them properly. Going back to this figure, it shows the cover geocomposite on the left side and the burrito for the rainwater toe drain system at the toe of the slope. And the flap you see out there next to the guy who's sitting down and cutting off the excess flap material. I'm gonna move fast. Like I said, with the terrace system, again, the same thing. I have seen terrace landfills cover system installed, but no toe drain system built into them. You need leachate toe drain system at every terrace. Next, you need a rainwater toe drain system at every terrace to address the liquid in the composite. This is a complex geometry that you have to be able to handle it in the field if you have a terrace system. Next. And also in the ditch next to an access road, you do need a rainwater toe drain above the geomembrane, cover geomembrane, and a leachate toe drain below the cover geomembrane. These are essential components to keep the system intact, stable, and this system have to be able to perform for a long period of time, maintenance-free.
So Ali, when you're doing, let's say, tack on, you're putting your rainwater above the liner to kind of toe drains. Do you recommend putting any kind of as you're going up the slope? Are you putting anything up on the slope where you have the tack on berms, or is it just kind of at the you're putting a layer of geotextile or geogrid above it, some distance up from the bottom?
On the tack on system, the geocomposite is straight up on a 3-to-1 slope.
How far do you go, all the way up, or just partial?
You go all the way up on a 3-to-1 slope. Of course, you construct them in partial closures.
Right.
You may, if your slope is like 450 long, you may build it 120 at a time, 3 partial closures, one on top of the other. So you continue the geocomposite above. Geocomposite drains the entire length. You need to design the geocomposite to be able to manage the liquid that reaches the composite. Of course, that's part of the design of the drainage layer in the cap.
Okay.
All I'm saying, modern landfills require sophisticated designs, and we engineers need to be able to come up with innovative designs, not only maximize airspace, make the systems that we design maintenance less. Reduce the amount of maintenance, because every maintenance, every repair that's done is the negative to the bottom line. And the intent is to maximize the asset and the bottom line of the landfill. With
Yeah,
that, if there are any questions.
I think as I during my earlier days when I was doing a lot of landfill, detailed landfill design, I mean, the approach I used to always take is I'm a drop of water. Do I have a place to call home? In terms of thinking about where could this cause me problems and just plan for it. Because these are like you said, life structures. So you got to think big, you got to think worst case, you're not going to be able to go back in many cases, go back to fix something that's buried under a couple hundred feet of garbage. So, you really have to think about that ahead of time and plan those structures. I mean, it's pennies really on the yard relative to the overall other costs associated with the landfill.
Very true. Another point that I'd like to get across at this point is that lining system has to perform during the life of the landfill, during the post-closure. Hopefully by the time you get out of the post-closure, there's not much issue with collection of leachate of that sort. That is the theory behind post-closure termination. But final covers is a different animal. Final cover you construct today has to perform 1,000 years down the road to the same level. These final covers, they go years and decades and hundreds of eons beyond the post-closure period. If these final covers stop performing, the system fails. And if the post-closure period is over, it would be on the regulatory agency and the public money to go back and repair them. So when you design final covers, this is my suggestion to you, over-design it. Be very conservative. If the geocomposite that you design, it needs to be 250 mil, make it 300 mil, as thick as you can, sell it to the owner, because it's their money on the investment. Make it as much as you can. You have seen hurricanes in recent days. You have seen hurricanes in the past. And we all know that climate change is going to bring a lot more rain onto our systems, including landfills. There's going to be a lot more water flowing through that composite that you designed today, 50 years down the road, still has to perform and keep this slope stable.
We have a couple more questions. We're at the top of the hour, and I want to respect everybody's time. So if you have to leave us, we appreciate you joining us for this webinar that we had today. But we're going to stay on for a couple of more minutes and answer some questions. Ali, one of the questions that came up here had to deal with the use of alternative daily cover systems, and does that help to provide additional airspace, just from a management perspective?
Yes, it certainly does, because you have to look at the sustainability aspect of these designs. Using alternative daily cover is a sustainability kind of act. Basically, what arrives at the site that could be used as daily cover, why not? Get it in the permit and use it. That's the sustainability part of it. Or from greenhouse gas emissions, the same thing. If bringing dirt to use a daily cover, it generates more greenhouse gas emissions compared to a waste that you receive and can be reused as daily cover. Daily cover, if possible, some regulations do not allow to be shaved off the next day. If possible, shave it off and make the day waste to come in contact with the yesterday's waste. That helps for the leachate to percolate down. I know a lot of operators do not like to shave the daily cover away and have waste in contact with the yesterday waste. But that's really one of the ways to eliminate perch zones of leachate within the landfill column.
We have this is kind of an interesting question in terms of dealing with just thinking, in terms of your thoughts on solar farms on closed landfills and alternative coverage for these types of systems where you're putting solar on landfills. Got any experience or comments on that?
Absolutely, I'm all for it, because solar farm can easily be constructed on the flat surface as well as southern slopes of landfills that receive a lot of sun because of the open space of the landfills. Also, they could be installed on undeveloped portion of permitted footprints. A lot of these side operations, composting, recycling, solar farms, all sorts of things can be within the future permitted footprint. If you have permitted, I have a landfill that I permitted, brand new landfill, 670 acres. This landfill will take a long time to reach some places that would become cells 50 years down the road. I have 50 years to use that space for all sorts of operations that come into the picture and generate revenue for me.
Very good. Well, Ali, thank you so much. I always find it fascinating. I learn something new every time I sit and listen. Always been amazed by the detailed thought that goes into every element. I love design as well, and I appreciate that. There's a couple more questions here. Gosh, they're coming in. So, in your opinion, is a tiered vertical gas collection system better than a horizontal gas collection system in terms of space, efficiency, construction-related complications?
Well, the tiered gas well system helps to not only vacuum the gas out of the entire vertical column of waste, also helps to get the leachate to the bottom of the landfill, to the leachate collection system that is so much investment in it. If the leachate cannot get to the bottom, become purge zones in the landfill, then it causes all sorts of other problems. Slope stability may be one. Elevated temperatures, another one that is a big item. We have had landfills with $200 million, $300 million set aside funds to address the elevated temperature in the landfill, just because of the thickness of waste and the amount of liquid inside the vertical column of waste.
And I
These
think
are all issues that can be addressed with the tiered vertical gas system.
and I don't think it's either or necessarily, because I think in terms of the spacing of, I'll call these these target gravel structures the tiered system, you can tie them in or have them intersecting or come in conjunction with horizontal collectors
Yes.
as well. So I don't think it's necessarily an exclusive issue, but it's a design issue that you have to consider and how you're going to ultimately achieve your NSPS compliance and coverage that you need for your gas collection and control system.
You're very correct. Liquid coming out of the horizontal gas system is an issue, but if you tie it to a tiered vertical gas system, liquid can be, you can slope the trench in such a way that would tie into one of these pads, gravel settings, and drain the liquid through the tiered vertical system to the bottom and not deal with the liquid in the horizontal gas.
Yeah, because that's probably one of the biggest challenges people have in terms of the bellying. As you put horizontals in, the bellying that naturally occurs in the pipes, which causes those horizontals in many cases to become ineffective pretty quickly. And so this might actually, in combination, help the process. Somebody asked the question, can a landfill be built to last 100 years?
Easily. As a matter of fact, Bob and I, we are both involved at the master planning for a landfill in California. There is an existing landfill which has another 30, 40 years of life. And through the master planning, we are giving them more than 100 years on top of that 30 years. It's easy to come up with the layouts if there is enough land to design a footprint to go beyond 100 years.
I think maybe one of the nuances of the question might have been in terms of the technology. I'll use the word technology or materials that we're using in our construction of our landfills and the cover systems. In terms of the longevity of those, I think maybe one of your points that you made earlier was make it as robust as you can so that it will deal with the long-term things that happen, degradation of materials, unexpected clogging, whatever it might be. If you make it a little larger, it gives you some room to run, so to speak, or room to wiggle.
Yes, and plan for using the maximum possible footprint that you can on a property. If you're preparing a permit application today, there's no reason to stop at 30-year life when you can develop a 100-year life and get it in the permit. If you didn't construct it 40 years down the road, so be it, but you have it in the permit.
Do you have any views relative to using retention systems or MSE berms for increasing cell airspace?
That is certainly an innovative way of increasing airspace. It's a complicated design. It's very detailed construction, and there is elements that has to be very thoroughly evaluated and closely monitored during construction.
One of the questions that was asked in terms of materials in gas, and I think most of the companies that we work with have specific specifications relative to how they want their horizontal and vertical wells to be constructed, whether it's PVC or HDPE. Obviously, I think it's also a function of what type of temperatures and structural things that you got to deal with in the overall construction. Do you have any 2 cents to offer with regards to materials?
In terms of materials, I would say the best kind of way to go by it is just look at the history of construction at different sites. If the PVC is not the most suitable pipe for tall landfills, go with HDPE. If heat generation is an issue with HDPE, go with another material, CPVC. And elevated temperature landfills, I know some elevated temperature landfills, they're using steel pipes as the casing for the gas well. It depends on the application. It depends on the conditions of the landfill. It depends on the elements that come into the picture of the survivability of the system that you design and construct.
Yeah, I mean, the way I always advise our young engineers is think. You know, we're being charged to do the engineering, which means look at the conditions under which this material is going to be subjected. What are the stresses that are going to be subjected to, and you anticipate to occur, the deflections. Obviously, you made the mention between PVC and HDPE. Well, one's a rigid pipe, a PVC, which could actually become somewhat ductile. You know, under heat, it can also begin to move a bit as well. But HDPE obviously is a much more forgiving relative to deflections.
If I make one comment, another aspect of all this consideration of sustainability is considerations related to effective designs, innovative designs that reduces construction material, increases airspace, reduces future maintenance. All of these are not in the sustainability plans of waste management companies, waste operators. They need to bring these elements into their sustainability plans. Their sustainability plans is really missing these elements. If you reduce your soil quantity for construction of a cell by 1/3, that is a sustainability matter. If you increase the airspace within the same footprint, this is a sustainability matter. If you're reusing alternative daily cover from waste that you have already received, this is a sustainability matter. These sustainability plans need to begin incorporating this kind of innovative things that come into the picture as part of design and permitting.
Great. Well, I think we are at 3:11, hour and 10 minutes into this, and I think we've come to the end of the questions. And again, Ali, thank you very much for an informative hour. Like I said, I learned something new every time I listen to you. So thanks again. And thanks everybody, all those that participated. We had a very robust group of folks on the webinar. We do this pretty much every month or every other month, depending on what's going on in the world. And we hope that you've enjoyed this. And we have a long-term set of webinars planned for the next 1.5 years, actually. So we encourage you to stay tuned relative to the topics that we'll be addressing. So thank you very much. And Diane, do you have any other closing comments?
Yes, just a couple. One for Charles. We do have in our Learning Center information about permitting and siting and anything you need to know about solar on landfills. You may want to take a look at that. It's in our video Learning Center on our website. Also, our next month, we'll be covering remote control and monitoring technologies. That should be a very exciting one. We have a lot of new information and a lot of new capability coming through.
Very good.
And thank you, everybody.
Thank you. Have a good day.
Thank you, Bob. Thank you, Dan.
Bye.
Thanks to the audience. I appreciate spending time with us.
Bye.